Welcome to the Marine Biologist podcast. Join us to discover the latest ocean topics from leading marine scientists and conservationists. The podcast accompanies the Marine Biologist, the magazine for members of the Marine Biological Association, and is presented by the editor, Guy Baker. We hope you enjoy this episode.
Welcome to the Marine Biologist podcast. We're honoured today to welcome Professor Stephen Hawkins, an experimental ecologist who's worked on rocky shores for 60 years. He's Emeritus Professor in the School of Ocean and Earth Sciences at the University of Southampton and Lancaster Research Fellow at the Marine Biological Association. Steve was also Director of the MBA from 1999 to 2007. This is the second of a two-part podcast in which Professor Hawkins reflects on predictions he and colleagues made 25 years ago. Back in 2000, Stephen Hawkins, Richard Thompson and Tasman Crowe began compiling a list of the threats they felt were most likely to impact the world's rocky shorelines over the coming quarter of a century. In this episode, Professor Hawkins revisits those predictions. Welcome, Steve. Can you give us some background on the original predictions paper?
I discovered a lot of old stuff when my room at the MBA was required by younger workers, and I was going through my basement at home and I found a manuscript of a paper that I was writing in the 1980s with Dennis Crisp, Alan Southwood and Bill Ballantyne and myself. And this paper was about it getting colder and about these warm water species getting less common. And I'd done this survey all around the range of the species in the UK and also in northern France. And I'd repeated work that had been done by Dennis Crisp, Alan Southwood, and a French guy called Fischer-Piet in the 1950s. And I was writing this paper until about 1986. And I never finished it because I was ill for a couple of years. And it was probably just as well that I didn't, because in parallel with the broad-scale survey, I'd actually set up a few long-term monitoring sites in the southwest, mainly at sites near where my mum and dad lived in North Devon. So I could go and visit my parents, and when my dad got on my nerves, I could go out and say, I've got to do some shore sampling, Dad, it's low tide. And I began to realise that the warm water species was beginning to increase in abundance from about 1986, 87 onwards, particularly from about 1990, there was a sort of a switch in sea surface temperatures off Plymouth in about 88, 89. And the sort of a cold spell, which has started in 62, 63, following a period of warming from the 1920s up to about 1959, seemed to have come to a halt. There was a very, very cold winter in 86, 87. I can remember I had a Finnish worker looking at a brackish water species of barnacle, which is invasive from the Baltic. I remember in Preston Dock making a hole in the ice to let the Finnish diver in. She was used to that, didn't worry her at all, but it was quite strange for us to see completely ice-bound saline docks in the north of England in 86, 87. But from about 88, 89 onwards, we started having much milder winters. There's a weather system called the North Atlantic Oscillation, and when it's positive, you get basically westerly oceanic weather. It's a high pressure system between Iceland and the Azores. But if you get a negative NAO, you get more continental weather, more easterly weather, colder, drier weather. And we switched to a lot of warmer, wetter winters. And I think I became pretty convinced that climate change was happening, and we were beginning to see levels of warm water species much higher than the previous warm period. So peak warm was 1959. And this was in discussion with Alan Southwood a lot. And yeah, probably the late 1980s. Before that, I have to say, I thought there were just fluctuations going on. But of course, this was early doors of the international, the IPCC, Intergovernmental Panel for Climate Change. And some of the early reports came out, and the physics is convincing. If you put carbon dioxide, water vapor, various nitrous oxides, nitrogen oxygen combinations in the atmosphere, methane, you're going to trap energy. So that, for me, the physics is incontrovertible. There's a lot of fluctuations in the Earth system. You know, the planet wobbles, sunspot, solar flux varies a lot. Alan Southwood did a lot of work on trying to work out whether sunspots as an index of solar flux were driving the fluctuations in the English Channel and the Northeast Atlantic generally. So I would say that the realisation came in the late 1980s, and it came in conversation with Alan Southwood, because we were seeing similar things with both warm water barnacles and limpets. And also we started seeing warm summers. I was based on the Isle of Man then, but we got a project from NERC, National Environmental Research Council, which Mike Burrows, who just finished his PhD with me, worked on, rescuing Alan's data and analysing it. And it's such a shame because the NBA time series stopped in 1987, just at the crucial point. But we analysed the data, and we published a very early paper which came out in 1995 from a conference in 1993, which combined Alan's plankton data, some fish data, Alan's barnacle data, and my limpet data. And I think that was one of the earlier, not the earliest, but one of the earlier publications. And it wasn't in a very good journal. It was a Journal of Thermal Biology from a conference in Durham. It was one of the earliest papers which came out suggesting that climate change might be happening. And even Alan Southwood in the 1980s spotted a disconnect between solar flux in terms of sunspots and what temperatures were doing. So I don't think he ever published it, but he was suspecting it in the mid to late 80s, which is a shame because that was just about the time that the NBA's long-term data sets were shut down.
And what three things do you think we should be most concerned about in the marine environment?
When you think about the marine environment, you've got to think about the interactions of global change, which, to be honest, we're not going to be able to do very much about for the next 50 to 100 years, even if all the mitigation measures which are in place, you know, I've got solar panels at home, I'm saving up for an electric car. Even those individual and state actions come in, there's still going to be a lot of inertia in the weather system. So I think we've got to always think about the interactions of global change with regional scale and local impacts, which actually we've got much more in our power to do something about. So take the English Channel and the Western approaches as a whole as an example of a heavily utilised sea. We did some work 10, 15 years ago with David Sims and Martin Jenner, where we looked at historical records of the NBA's fishing activity. We resumed many of the time series for a few years. And one of the things that we showed was that climate change was interacting very strongly with fishing pressure in determining fish populations. So the three things for me are global change, which includes climate, and also on a longer time scale, maybe 100 years, shifts in biogeochemical cycling due to ocean acidification, which is not strictly climate change, it's a global biogeochemical change. We should consider those. There's so much invasion of non-native species at the moment due to globalization and trade. I view that as a global change phenomenon these days. So those are the three global things we need to worry about. But what actually causes most damage to the marine environment on shelf seas? It has to be fishing. And moving towards more sustainable ways of fishing, putting in place marine protected areas to at least relieve some areas from fishing pressure, particularly bottom trawling and bottom dredging is important. And I think so three things are global change, fishing. The third thing is inappropriate coastal development, which is actually at a local scale, but it tends to scale up to regional scales as every local authority does their own adaptational work to climate change, rising in stormier seas, builds another sea defence, and also how property, which was built in the 19th century, sometimes even in the 18th century, where a lot of land was won from the sea by reclamation, to defend that land in face of rising sea levels and stormier seas due to climate change, that's causing large-scale coastal modification and habitat loss. So my three main concerns are global change, which includes both climate and ocean acidification, and global homogenisation of faunas and floras due to invasive species. Fishing and exploitation of stocks also can include seaweed, which I reckon occurs at a regional scale, and at a local scale, scaling up to a regional scale, inappropriate coastal development, leading to habitat change, degradation, basically shifting a lot of soft shore environments to hard shore environments. And of course, with intelligent eco-sensitive design, you can mitigate some of these impacts by making artificial shores more attractive. But you should always ask the question, should we be doing this? And obviously in some places where there's infrastructure, property and life's at risk, you've got to defend. But in other parts of the country, I think we've got to take a much more managed retreat approach to rising sea levels and stormy seas. And that is current government policy, particularly in the east of England. So, yeah, those are my three categories of concerns, in which there's several concerns nested within them.
I was interested in if we could talk about the Hindsight Informs Foresight paper briefly. I was interested in a bit about plastics, and that it was interesting to see that the extent of that problem hadn't really been noticed in the early 2000s. And the other thing was the part about coastal water quality and urban runoff. I'm interested in that link between people getting more conscious of freshwater quality and bringing water companies to account for the failings there, and also runoff from roads affecting rivers, and that link in the public consciousness between the freshwater environment and the nearshore marine environment.
The paper that we wrote in 2001, 2002, was for a conference on environmental futures of aquatic ecosystems, which was held in Zurich. And I was invited to write the paper. And at the time, I was very busy. I think you might have been working at the NBA in 2001, 2002, because there was quite a strong rearguard action on stopping the place from being closed down, and the Natural Environment Research Council completely withdrawing its funding of the laboratory. So I was a bit preoccupied, but I engaged at the time I was invited, which was about 2000, both Richard Thompson and a guy called Tasman Crowe, who's now Pro Vice Chancellor, I think, Sustainability at University College Dublin. Were both doing postdocs with me, or had just come to the end of doing postdocs with me. And Richard had been my PhD student working on the shores. Richard and I had written a paper the year before, which was an invitation from Marsh and Attrell at the University of Plymouth to write a paper about impacts on rocky shores. So I accepted the invitation, but I got Richard and Taz to take the lead on a lot of the writing. I was involved in the overall direction of the study. And the paper itself, we had to keep it within a certain page length, because the idea was that we'd publish these papers ahead of the conference. And then at the conference, they were going to invite other experts on lakes or rocky shores or rivers to come and critique the papers that had been published. So we wrote we wrote the paper, and Richard Thompson was the lead author at the time. We did, and somewhere in the original Thompson et al. Paper, there is a caveat saying that we've written about things that we know about and are interested in. So we were preoccupied with oil spills, which I was working on at the time, tributyl tin pollution, which the MBA did a lot of work on, and I was peripherally involved in, with a few students jointly with the MBA over the years, looking at recovery after the ban of TBT. We're aware of climate change, but we wrote this paper in 2001, and that's before many of the papers that we published in the early mid-2000s after the Markland project started. Came out, but we were aware of climate change. We talked about climate change. And we were aware of other sources like sedimentation and other things. And we just basically tried to come up with a very simple matrix of what we thought the impacts were in the past, and then we had to make a 25-year projection. Now, it seemed appropriate to revisit this. And when Richard Thompson, Louise Firth, and I ran the International Temperate Reef Symposium in Plymouth in 2011, we had a short, somebody cried off because they were ill. We had a short discussion section looking at this, and we tried to get some idea. And a book came out of my retirement conference in 2015, which appeared in 2019. And the last chapter of that was mainly on rocky shores. And we asked all the authors who'd written chapters about Hong Kong and China, Australia, New Zealand, the west coast of America, east coast of America, Chile, Argentina and Chile, to come up with what they thought were the most important impacts. So there was an initial attempt in the final chapter of that Cambridge University book at doing that. But there was an opportunity for me to go to a pollution conference in Hong Kong in 2024. And I sort of thought, oh, well, this would be an interesting thing to talk about. So I sent in an abstract, and I gave the talk as a keynote paper at the beginning of the conference. And I did it in a fairly light-hearted way. In fact, I was basically criticising what we got right and what we got wrong with like a mark sheet. And a few things was, we thought, well, what theoretical framework was that based on? With WTF as the acronym on the abbreviation on the slide. So, and it was sort of it was meant to be an amusing talk. And then we were asked to write it up for the proceedings, which came out in Marine Pollution Bulletin, which I did. And I invested a little bit of money in involving Katie O'Shaughnessy, who was a student that Louise Firth had supervised on basically artificial shores and eco-engineering, and Richard Thompson, who co-supervised. I engaged her to help put the paper together, and she did a lot of the grunt work. But it became very apparent that lots of things had emerged since then: noise pollution, light pollution. Richard Thompson was already working on plastic pollution at the time we wrote the paper, which he was always doing on the side when he was meant to be working with me on limpets and seaweed interactions and microbial films. But at that stage, he didn't have any real data, but he was aware it was a problem. So a whole host of things have come to pass since. And we got a few things right. I mean, oil spills have gone down. We got a TBT. We got partially right. We were quite pessimistic about it, but actually once the International Maritime Organization ban came on and the EU banned it, lots of other legislations worldwide banned tributyl tin-based paints. And I mean, this stems back to work which was done in the 1980s by the Marine Biological Association, by Jeff Bryan, Peter Gibbs, Bill Langston was involved in it. So the MBA really highlighted the use of simple dog whelks as indicators of tributyl tin pollution and how masculinization of females by the TBT interfering with the hormones leading to females having a penis and then eventually leading to sterility of the females and eventual death, because the vas deferens would block the egg duct and then the poor females would explode. That was very much MBA work, and we were very aware of that work. We were also aware of hardening of coasts, but at the time we thought, well, this is probably not a bad thing for rocky shore plants and animals. It's a lot more habitat, even though it's a slightly impoverished environment. What the Germans would call an ersatz environment, so with the implication it's a substitute, but a poor substitute. So we perhaps weren't aware of the downside, and since then a lot of work showing that these highly simplified artificial structures show a lot of proliferation of non-native species, and that there's a lot of indirect effects on the sediment community. So perhaps we're a bit positive on that. So getting back to plastic, at the time, Richard was aware of it as an issue, but he hadn't really done any work on it. And for a long time, he really struggled to get funding for it. You know, he applied to NERC and referees to say it's not an important issue. But he eventually got some Leverhulme funding. And the seminal paper, which Richard published in 2005, I think, in Science, involved work with the Continuous Plankton Recorder, which was then the Salister Hardy Foundation based in Sidwell Hill, where he went through the silks, which were silk, no artificial fibres involved in those, and was able to pick out the first appearance of plastic fibres across the Atlantic. And Richard worked for a bit with me in Southampton, and he made a liaison with some of the people in the chemistry department in Southampton who were using infrared Raman spectroscopy, which allows you to identify unequivocally plastic particles from their fluorescent signature. So that paper came out, but at the time of writing, it wasn't there. And Richard, who was co-lead author on the first paper and last author on the recent paper, Richard Thompson's really involved in trying to get a new United Nations treaty on control of plastic in the environment. So it's interesting that something was a side hobby is now his major preoccupation, and it was great to see that he received a fellowship of the Royal Society and an OBE to mark his amazing contribution. And really, Richard struggled with funding for a long time, way up to 2010, and then there was an explosion of interest. So it's amazing to see how that's taken off. And I think at the time we were aware of eutrophication. We thought, we were in the UK was in the European Union then, and all these great things that come from the European Union, like the Water Framework Directive, the Nitrogen Directive, Urban Wastewater Directive. So certainly Europe and the US was really cleaning its act up on inputs of nitrogen and other nutrients from both sewage. Sludge disposal at sea was banned by the EU sometime in the 1990s, but also from trying to get agricultural runoff tightened up, which is probably the major impact of eutrophication. So we're aware of eutrophication, but I think we were over-optimistic that progress in Europe would continue and be adopted worldwide. And I think many other parts of the world still dump sewage at sea. Agricultural intensification, I think, has really led to greater use of artificial nutrients on agriculture. And also agricultural intensification, particularly the switch from pastoral farming to arable farming, means you get a lot more soil coming off the shore. And I think what's beginning to be realised in the last 20 years or so is it's not just the nutrients which are important, it's the sediment load, which of course is made worse by the fact that in many developed parts of the world, estuaries have been canalised, fringing marsh has been got rid of. Basically, any meanders in estuaries have been taken out for navigation purposes. So a lot of the natural mechanisms which would have been filters for both nutrients and sediments in upper marshes, upper reaches of estuaries, salt marshes lower down have been taken out. And then on top of that, and again, this is work that Richard Thompson's been involved in, looking at things like tyres. And also Taz Crowe was involved in a bit of work on polyaromatic hydrocarbons, which are basically petrol waste, which, any of you had a car in the 1970s and 1980s would know just how much oil used to drip on the pavement outside your house. There's a lot of that gets on roads. So I think this combination of both agricultural and urban runoff, not just nutrients, sediments, and also associated pollutants from agriculture, things like pesticides, from roads, particularly road runoff associated with erosion of tyres and hydrocarbons. I think that's something which has really increased. And I was at a temperate reef conference about a month ago, and there were several papers on what's now called ocean darkening, which is basically there's less light penetrating the oceans. And some of this is due to more phytoplankton, due to eutrophication, more nutrients, but a lot of it's due to sediment loads. And also sediment loads have a very bad effect in coastal environments, because once you get a lot of sediment, it favours algal turfs, and you often get a shift from kelp-dominated communities or large fucus-dominated communities, large brown seaweed communities, to ones dominated by algal turfs which trap sand. And once that happens, they dominate space and can lead to total degradation. This has been shown in work in Australia, it's been shown in work in the Mediterranean, particularly by Laura Araldi, and it's been shown by work in the UK. So I think we've really realised that you need to take a whole catchment to coast approach, and actually managing, water runoff in urban areas is particularly important.
What advice would you give to a young person who wants to be involved in marine biology?
Get out on the seashore, get your wellies on, go and poke around sandy beaches and the strand line, and go and have a look at rock pools. Go to your local estuary and sort of just have a look at how things change as you go from the sea up the river. I think the biggest thing is just to go on the seashore, have a look, because the seashore is most people's window on the ocean, and you don't get seasick.
Thank you very much, Steve. Just remains to say it's been a fascinating, wide-ranging discussion, and we wish you well in your future endeavours. And we hope to see you back on the podcast or in the magazine very soon. We hope you enjoyed the podcast. Become a member of the Marine Biological Association and be part of a global community advocating for the ocean. You'll receive 4 copies of our beautifully produced magazine, Marine Biologist, and a host of other benefits. Simply visit www.mba.ac.uk for more information.